Okay. Second experiment, demonstrate the verification of Thevinins theorem. So this also I'm going to show the demonstration using a simulation tool, which is a Multisim 14.2 version. So open the tool. So since we are doing new design, click on new file. Okay, new design and blank create. So another new window open with blank screen. Now you can demonstrate Thevenin's theorem for any circuit. So let me take the same problem which we did for superposition theorem. So here instead of superposition theorem, find current through 20 ohm resistor. Find current through 20 ohm resistor. This time we are using Thevenin's theorem. So the statement of Thevenin's theorem is Thevenin's theorem states that it is possible to simplify any linear circuit irrespective of how complex it is to an equivalent circuit with a single voltage source and a series resistor. So this is a complex circuit, right? So it is having three meshes, mesh 1, mesh 2, mesh 3. So to do the analysis, you have to write the mesh equations for all this and you have to verify. So instead of this complex circuit, you can replace this entire circuit with one voltage source and only one resistor is enough. Okay. So question is what value we have to take for the voltage value and what is the resistance value. So in order to find the voltage source, we have to remove the load. So which is the load in the circuit is here they ask to find the current through 20 ohm resistor. So this you have to consider as load. So you have to remove the load and you have to find out what is the open circuit voltage appearing across this. Okay, you have to open circuit this. You have to find out open circuit voltage across this. That is the voltage value you have to use in the simplified circuit. And what is the resistance value you have to use in that is you have to make all the sources as zero. If it's a voltage source, short circuit it and make voltage is equal to zero. If it is a current source, open circuit it and make current is equal to zero. And with the RL is removed, looking through the RL terminals, you have to see what is the equivalent resistance looking from that side. So now I will rig up this circuit. Okay, after that first I will find out if it is correct, whatever current is flowing in the complex circuit. In the complex circuit, 20 amps, 20 ohms is the load. Okay, and you have to find out the current value here. Okay, same current you should get from the Thevenin's equivalent circuit. So first I will show, I will rig up this circuit and I will find out what is the actual current flowing here without applying Thevenin's theorem. What is the current? We'll do the verification with the simplified circuit also. So I'm going to Multisim. So place comp. First you have to see if any previous program is running. You have to stop it. Okay. Now for to place component, four resistors you have to select. So one voltage source is required now. So DC power. One current source is required. Signal voltage source. It should be database should be master database. All the sources, current source voltages are available in the group sources. So power sources will get voltage, AC power as well as DC power. In the signal current source, AC current is there, so DC current is there. You can select this. After that, four resistors. I already told resistors are available in the basic group. So select the resistor value. So we want 10 ohm. So by default, it will pick 1K. So if you want 10K, you can directly select 10K, 10 ohm here, or that 1 ohm on that 1K only, double click and you can change the value. Okay. So I will take here, for example, I'll take 5 ohm here. Okay. 4 resistors I want. One is 5 ohm. Next is 10 ohm. You can double click and change the values also later if you want. So if you want to place horizontal vertical, control R. Okay, once again you want same 10 ohm. Once again one more resistor with the 20 ohms. You can you can drag here or you can place, and later you can double click and change the value to any suitable value. So this 20 ohm vertical position, control R. Okay, one ground will place. That ground is available in sources, power sources, ground. So this value, current value is 4 amps. So click on this and change the value to 4 amps. Similarly, voltage value, you change it to 20 volts. Okay, now make the connection fast. Click and go outside. So you cannot start from here. So to at the edge of any component, you can connect. Here it is not possible because it is not the edge. So here you can start. So here I think we can find out current through 20 ohm resistor using this. Now you can connect one ammeter current probe. So here it will show. So now let me run this. You can see what is the current flowing through this. So note down overall current, actual current flowing. This is normal. We are not applying any Thevenin's theorem. So this current you should get in the reduced Thevenin circuit. So expected current in the Thevenin equivalent circuit is also 2 amps you should get with the reduced simplified network, which consists of one voltage source and one resistance. So then your Thevenin's theorem is verified. Okay. So now to find what is the value of that voltage source and resistance. Okay. So what is Thevenin's theorem states that any complex circuit, for example, this is a complex circuit, right? This can be replaced by one voltage source. So I don't know what is the value of voltage and what is the value of resistance. I will just write here. Uh, okay, later I will do that part. So first I will find out what is the voltage source means. You have to find out open circuit voltage across this. So copy the entire circuit, Control C, and you can place here, Control V. Okay. So now you have to remove the load first. First step is you have to remove RL. Okay, this is the RL because we have to find out current through 20 ohms. So we have to remove the RL. So remove RL. This current source also you can remove. So now we have to find voltage between this current, this load. So with all sources acting, this current source and voltage source are acting together, you have to find out open circuit voltage across this. So take a multimeter So this is a multimeter I'm placing here. Connect positive to here because RL was here, no 20 ohms was here. So at the place of RL, you have to connect one meter, voltmeter. So this should you have to measure resistance. So in the multimeter, the switch should be resistance. So A means by default voltage will be there. A means current ammeter. V means voltmeter. This is resistance measurement, ohm meter. So click on this ohm symbol. So now it will give. So actually open circuit voltage, no? So voltage, it should be voltage. For finding resistance, it should be here. So it should be in volts. So now if I run this, it will show here. We remove the RL. We remove the RL, and it will show open circuit voltage because we removed open the load, and across that we are finding voltage. So what is the Thevenin equivalent circuit voltage? You can see now. Yes, it's coming as 66.66 is the VTH value. So how we calculated? We removed the load with all the sources acting. Just we removed the RL, and we with the help of multimeter we calculated this. So theoretically also you can find out the voltage across this. Okay. So after this, now we'll go to, you have to find out what is RTH. To find the RTH, okay. So you have to make all the sources as 0. So stop running. Copy once again this circuit we calculated VTH. I'll write down here VTH showing 66.6 now. So if you want, you can place here fixed also. Open circuit voltage VTH is equal to 66.6667 volts. So next, copy the circuit and paste once again. Now we have to find out what is RTH. Okay, to find the RTH, again you have to remove the load. You have to make current source is equal to 0. Current source is equal to 0 means open circuit, delete it. And voltage source is equal to 0. Voltage source is equal to 0 means short circuit. So voltage circuit is short circuited. Current source is completely removed. Now here actually between this and this, looking from load terminal, what is the equivalent resistance you have to see. So it is theoretically it is equal to 5 parallel with 10. See here, this is short circuit now. Between these two nodes, 5 ohm is there, 10 ohm is there. So 5 parallel with 10. What is the equivalent resistance of 5 parallel 10? It is 5 into 10 divided by 5 plus 10. So parallel combination of R1 and R2 is R1 R2 divided by R1 plus R2. And that is, we are going to get some equivalent resistance that will be in series with this 10 ohm. So this you can check with the multimeter also. Take once again multimeter. This you have to keep it in ohms. Okay. So connect positive here. Okay, this now keep it in ohms. Okay. Now I don't want current. So you can remove this current. This is not required. So it will show what is the resistance value now. It will show what is the resistance value. So let me check what is the resistance value. It is 5 parallel 10 plus 10. So 5 parallel 10 is 3.33 in series with the 10. So 10 plus 3.333 is plus 13.333. So now we got the value of RTH and VTH. VTH is 66, RTH is 13.33. So I'll write a here one text box to indicate what value we got. So RTH we got as 13.33. That is Thevenin's equivalent circuit resistance. TH is equal to 13.33 ohms. So now we have to write one equivalent Thevenin's equivalent circuit. It consists of voltage source of 66.66, resistance of 13.33, and you have to connect the same RL which we removed. We removed 20 ohm, no? Same 20 ohm you have to connect in series with that circuit, and you should expect 2 amps only. Then Thevenin's theorem is verified. So stop the circuit. So place component. So you can copy any voltage source if it is already copied, no? Just Control C and Control V. Control C and Control V. It will, this value you have to change what? 66. Otherwise, you can go to place component sources, power sources. You can select that and you can. So this value you have to set to VTH of 66.667, and the resistance also you can copy. Any resistance you copy and paste. So one more resistance we want now, RL. So once again Control V, and this you Control R, vertical. So this is RTH, because Thevenin's theorem states that any complex network can be replaced with voltage source in series with resistance. What is the value of this voltage source is? What is the value of this voltage source is? You have to open circuit RL, and you have to find out open circuit voltage across this. To find this, you can do theoretical analysis, but in the lab you can check the open circuit voltage with a multimeter, keep it in volts, and find the voltage. That voltage value you have to set in the Thevenin's equivalent circuit. And to find the RTH in the lab, voltage source you short circuit, current source you remove. Open circuit means remove. Short circuit, this is your short. Now we got using multimeter, keep it in ohms, and we got 13.50. Same value you have to connect here. And for RL, you have to connect. For RL, you have to connect which load we removed, no? Open circuit voltage. Same RL you have to connect. This is 13.333 ohms. So RTH is this much, VTH is this much. So if you want, you can rename this as VTH, no problem. Label you have to change, not the value. Label of any power source instead of V1, V2, V3, no? So this is value. So label also, if you want, you can change this to, instead of V3, you can give your own label as VTH, Thevenin's equivalent voltage. And similarly for resistance also, you can double click on the label, and you can change the label value as RTH instead of R11. You can rename it as, in the circuit, no two resistors with the same label. So that's why automatically it will change, the resistance value will be increased, R1, R2, R3, and like that. So only one value in the circuit. Okay, RTH. So now RL is how much? We removed RL, no? This R4 is nothing but RL. So double click on this. RL value is 20 ohms. Okay. And what is the expected current? If the Thevenin's theorem is correct, whatever current is flowing in the complex circuit. So in the complex circuit, current flowing through this R4 is 2 amps. This is we did with the simulation. Okay. So now uh, with the simplified circuit, also it should give the same current. So now let us verify this. So copy the ground also and paste here. Any ground you can copy and paste. Any resistors you can copy and then later you can change. Now current value we want. So current value you can connect one. Let's see this current probe. I selected from here. Now I am running this. Okay, I can verify here. Current in the simplified Thevenin circuit is 2 amps. So in the complex circuit also, the current in the 20 ohms is 2 amps only. So this is the verification of Thevenin's theorem.